This section is 6.7 and it covers multiplying and dividing complex numbers. The thing that I need you to remember is whenever you have the square root of a -1, it's gonna be I. So, and it's important because we have been pulling out the negative as being I. Now, if we were to square the I, it's interesting what we come back to. We end up with I squared equals a -1. So you have to remember, this is something you need to memorize. When I squared is always a -1. And that's going to come in handy because we're going to be multiplying and dividing. You're going to have to remember that when you have something that's I squared, it equals a -1. The i's disappear and become that -1. So we have this problem of 4 minus 3i times 2 plus 5i. Of course, we're going to FOIL this. We're going to do f, which is 4 times 2 is 8. Then we're going to do our O, which is outside times outside, and you can multiply these because remember we could do 4 times 2a or even x, it becomes 8x. So you can multiply these. So you get plus 20i. Then we're going to do the I, inside and inside. We got a negative times positive, which gives us negative. 3 times 2 is 6, and then we have our I. And then we're going to do the last times last. Negative times positive is negative. 3 times 5 is 15. Then we have I squared. Now, I just showed you how when we have I squared, it gives us a -1. So, anytime you see an I squared, you can just cancel it out and change the sign of whatever's in front of it. So now looking at this, we have our imaginary parts here and then our real parts here. So if you add them together, the real parts, you get 23. And then subtract 6 from 20, you get positive 14i. And that's simplified. We're done. Now let's look at, we have I square root of 11 times 5 minus 6i. We need to FOIL this through, or not FOIL, distribute it through. So we have, and this is when it becomes key to remembering, multiply your signs, then multiply the outsides, then multiply the insides. Very crucial. So we have positive times positive, which is positive. We have 5 times I, which is 5i. And then we have square root of 11. And then we have positive times negative, which is negative. We have 6 times 1, which is 6. I times I, which is I squared, and the square root of 11. Now you have to remember, I squared changes the sign. This becomes our real portion, and this is our imaginary portion. So, to write it in standard form, you have to put the real first. We have a positive 6 square root of 11 plus 5i square root of 11. And that's our standard form. Okay? Whoops. Standard form. Do another one. We have negative 4 minus 3i times 5 minus I square root of 7. Again, let's FOIL. First times first, which is negative 4 times 5, which is negative 20. Outside times outside, so our sign times our sign. Negative times negative is positive. 4 times I is 4i. Then we have square root of 7. Now let's do inside, inside. Negative 3 times positive 5 is negative 15i. And then we're going to do our last. Negative times negative is positive. 3 times 1 is 3. Then we've got I squared and then square root of 7. We can change the I squared. That would become negative. So now we have to find our real numbers and our imaginary numbers. Here's an imaginary and here's imaginary. This is now real, that's real. So we have to add those together. And anytime that we have more than one group, because we can't add those together because one's is a radical and one's not. So we have to keep them like this, and we're going to put them in as their own group. Then we're going to, I think we're going to add that because we have an I in common. So we're going to have I, and what's left? 4 square root of 7 minus 15. And that is our answer. And it is in standard form because the real part's first, the imaginary part's second. Again, you can put the I in the front or in the back, it doesn't matter. Now we're going to build on what we've learned. So we have this problem. We have negative 3 minus I square root of 5 over 8 plus I square root of 6. So how do we simplify this? We have a radical in the bottom. We've got to get rid of it. And there's two terms. So we have to multiply it by its conjugate. So we have 8 minus I square root of 6 on the top and the bottom. Remember, when you multiply by the conjugate, you're just going to do the full part, the F and the L. So that gives us, on the bottom, it gives us 8 times 8, which is 64. Then we have I times, positive times negative is a negative. We've got I times I, which is I squared. And then we have 6 times 6 inside, which brings a 6 out. So, have to take care of this negative. I squared would be a negative 1, so it changes our sign. So 64 plus 6 is 70. That's our bottom. Now let's do our top. This one we're going to have to FOIL. Okay, so we've got, I'm going to write that down here. We've got negative 3 times 8, which is a negative 24. We've got negative 3 times negative I, which is a positive 3i square root of 6. We've got a negative I times 8, which is a negative 8i square root of 5. Then we have our last times last. Negative times negative is a positive. Then we've got our I squared. And then we can multiply those because they're inside. So we have a square root of 30. 3 and 10. And then and 5 and 2. There's nothing that'll pull out of that one. So we need to look and see if we have any like terms. That's just a number. Oh, we need to get rid of this, make it negative. So we have a real number here, imaginary number here, imaginary number here, and a real number here. So we have to get our real numbers together. So we have negative 24 minus square root of 30, and that's in one group. And we want to pull out our positive I here. And what's left? We have 3 square root of 6 minus 8 square root of 5. And all of that is over 70. And that's our answer. Now, Miss Malone does this a little bit differently than I learned how to do it. We know that I squared equals a negative 1. And so when you have I to an even exponent, you're going to end up with something that is 1 or a negative 1. And when you have I to an odd exponent, you're going to get I or a negative I. Now, if I remember this right, if you can remember to write this little chart, if you have I to 0, anything to the 0 power is 1. This is how I remember it. Then if you have I to the first power, it's just going to be I. Remember odd, it's going to be I. Then if you have I to the second power, it's going to be negative 1. See, even, 1 or negative 1. And then I to the third power is going to be, well, you've got I times I, which is a negative 1, and a negative 1 times I is a negative I. And then up here, it just kind of repeats and starts going. So you have 4 of them. The way Mrs. Malone does it, you need to memorize these. If you can remember this or this, you're going to be good to do this section. She has I to the 16th power. And she says we want to know if it's going to be even or odd. So what you need to do is you need to have I squared. And what would this power be to get 16? It would be 8. Well, that's an even number. So you're going to have a negative 1, because I squared is a negative 1, to the 8th power, which is going to be an even, which your answer is going to be 1. Same thing with I to 384. If you make them in half, it's going to be 192, which that's going to make it an even, which is going to yield you with a 1. I'm going to show you 2 different ways to do this, and then it's up to you to find one that works best for you. This one here is going to give you an odd one, which is negative 1 to the odd, which is going to yield a negative 1. So, but if you use the method that I have over here, all you have to do is we have 4. If you take 16 and you divide it by 4, you're going to get 4. So 1, 2, 3, 4. Let me think. Okay. Anytime you get anytime you get an even number with no remainder, it's going to be 1. See, 1? Because this is 0 remainders. So it's going to be 1. So if you take 384, like this next one, and divide it by 4, I'm not in the right spot. Sorry about that. If you take 384 divided by 4, you're going to get 96. It does not have a remainder, so that answer is going to be 1. Now if you take 386 and you divide it by 4, you're going to get 96 point, probably 96 times 4 is 384. You're going to get a remainder of 2. So if you look here, we have a remainder of 2, so it's going to be a negative 1. And if you look, it gives us the same answers as we got before. So it's up to you. You can either remember it this way up here, and this is Mrs. Malone's way of explaining it. And I don't know where I come up with this. Somebody had this explanation that's how I learned it to begin with. So let's practice a few more of these. We have I to the 15th, and if you broke it down to where you had an even number, you're going to have 15 divided by 4, 3, 12, with a remainder of 3. So we can, all we're really concerned about is this remainder. So the remainder of 3 on our list before was a negative I. Of course, Mrs. Malone broke it down to where it was, you would have I to the 14th times I to get I to the 15th. And this would be I squared to the 7th times I, which it's odd, so negative 1 was with an odd I gives you negative 1 times I, which is negative I. Oops, circled the wrong thing. All right, now we're going to divide. We have (7 plus 3i) over negative 5 plus 4i. So we know that to get rid of the imaginary on the bottom, we multiply by its conjugate. This will give us first times first, last times last, which gives us, we have to FOIL the top, which gives us a negative 35. Then outside times outside is negative 28i. Inside times inside is a negative 15i. And the last times last is a negative 12i squared. And then it's over negative 5 times negative 5 is 25. And then we have minus 16i squared. Now we need to remember and take care of our I squareds. We have got one in the top, which changes the sign, one in the bottom that changes that sign. So we need to look for our real numbers and look for our imaginary numbers. This is real, imaginary, imaginary, and real. So we want the real to be out in front. We've got negative 35 plus 12, which is negative 23. And then we've got negative minus, so that's minus 43i for the top. And what do we get for the bottom? 25 plus 16 is 41. And there we go. That's our answer. We're done for that one. Okay, slide this up here. We've got I square root of 6 times 6 minus I square root of 3. We need to distribute this through. So we have I times 6, positive times positive, which is 6i square root of 6. We have positive times negative, which is a negative. We've got I times I, which is I squared. And then we've got 6 times 3 inside, which is 18. Now, let's see if we have anything that we can pull out of that. Oh, we've got 2 goes into that, 9 times 3 times 3. Ooh, we've got a pair of 3s. So we have, if you look at this, we want to take care of that. It changes our sign. So we have 6i square root of 6, and then we have minus 3 square root of 2. Okay. And the reason why I was taking so long is because I couldn't figure out why she had these backwards, but in standard form, you always want to write the real part and the imaginary part second. Real part first, imaginary part second. Why? Oh, I made a mistake. This one's positive because, see, back here, the I squared changed that to plus. So we have 3 square root of 2. We can't really add those two together because, for one, this has an I and those are not the same inside the radicals, so we can't add them together. So we have 3 square root of 2 as our real portion, and then we have 6i square root of 6 as our imaginary part. And it's written in standard form. Okay. I'm going to need to show you. -2 times square root of 7 plus 4i. Okay, again, we're just going to distribute those across. So -2 times that, we're going to times it by what's outside. So we've got a -2 square root of 7. Because remember, you can't times what's inside with what's outside. You have to go outside times outside, inside times inside. And then to do this one, we've got negative times positive is negative 8i. This is our real part. And I missed something, didn't I? Yes, I did. This was a negative. I couldn't read my writing. This was a -7, so this would be positive on the outside. Let me rewrite that. -2 times negative square root of 7 plus 4i. Now you can see where we had a -2 times a -1, which is a positive 2 square root of 7, plus, which would be minus negative times positive. Now you can see why I always do the signs first, because it gets so tricky trying to remember all this. Signs first, then the outside numbers, then the inside numbers. And it is in standard form because the real numbers first, the imaginary second, so that's our answer. We've got 2i square root of 2 times 4 plus 6i. Alright, we're going to FOIL this one as well. First times first. 2 times 4, and they're both positive, so it's 8. Then we're going to do the O part. Outside times outside. Positive times positive is positive. 2 times 6 is 12. And then the I just tags along. Now we're going to do the inside. Negative times positive is negative. 4 times I is 4i. And then our radical tags along. Then we're going to do last times last. Negative times positive is negative. 6 times 1 is 6. I times I is I squared. And then our radical just kind of tags along with it. Now we need to make sure we go back. We got our I squareds here and change our sign. So now we have our real numbers is right here and right here. And we can't really add them together because one has a radical, one doesn't. So we're have to write them like this. And then we're going to add I. We're going to pull an I out. And what remains is 12 minus 4 to the square root of 2. And that is our answer. Okay. Let's do some more of these. Make our little chart. I to the 0 is 1. I to the first is I. I to the second is -1. I to the third is -I. They alternate. Positives first, then negatives. So if we have I to the 20th, what is that going to be? We have 20 divided by 4, and it goes in evenly 5. So we're not going to have a remainder. So it's going to be 1. Just like we don't have a remainder. 0 is 1. Then I to the 302 gives us, if we have 302 and we divide that by 4, we're going to get 75 something. 75 times 4 is 300, which gives us a remainder of 2. We're going to look at that remainder. We have a remainder of 2, so our answer is going to be -1. And then I of 23. If you take 23 and you divide it by 4, well, we got 5, which gives us a remainder of 3. So that's what we're going to look at. Remainder of 3 gives us a -1. Or, I'm sorry, -I. I think it's easier to do it that way. If you can remember to write the chart this way, that is a very simple way to remember it. Okay. We've got 2 more problems. We've kind of done some similar to this. We have 9 plus I square root of 7 and 9 minus I square root of 7. If you notice, those are conjugates of each other. So whenever you do conjugates, you're going to have just the first times first and the last times last, because the outside and inside are going to cancel each other out. So if we get 9 times 9 is 81. And then if you have negative or positive times negative is negative. I times I is I squared. And then you have 7 times 7 inside a radical pulls out a 7. Right? So now we need to make sure we take care of our I squareds, make it positive. So we have 81 plus 7, which is 88. That's our answer for that one. And our last one is 8 plus 2I divided by -7 plus I square root of 5. Now, again, we're going to use our conjugate because there's 2 terms in here to divide. So if we take it times its conjugate, we're going to have first times first, last times last. So, kind of writing big, aren't we? We have to FOIL the top, which is 8 times -7 is -56. 8 times -I is -8I to the square root of 5. Then we have -7 times 2I is -14I. Then we have negative, positive times negative, which is negative. Then we have 2i squared to the square root of 5. So if we take care of our I squared and change our signs, we have, here's our imaginaries and here's our reals. So we want to keep them straight. I'm going to go ahead and write those down here. We've got negative 56 minus 14i as our reals. And then we have plus I, got negative and positive. Oh, never mind. I was looking at this one. That's part of my real ones. We have, these are imaginaries, so they're both negative, so we could actually pull out a negative I. And that would leave us with 8 to the square root of 5 minus 14. Oh, nope, we pulled out a negative, so this is positive 14. So that's what's on top. Now let's figure out what's on bottom. Negative 7 times negative 7 is 49. Then we've got a negative, then we've got I times I is I squared, and then we have 2 5s inside, which brings that a 5. This I squared makes it positive, so we have 49 plus 5 is, I think, 54. So to rewrite this to where it looks a lot neater, we've got a negative 56 minus 14. What did I do wrong? Because that's not the same answer that I come up with earlier. Negative 56. Oh, I get royally goofed up. Okay. I goofed up because I took something up here. Alright, starting over. We have 8 plus 2i over negative 7 plus I square root of 5. So we're going to multiply it by its conjugate. In order to do this. So we have to take and FOIL that out. So we get negative 56. And here we have a negative 8i square root of 5. Here we have a negative 14i. And then we have a negative 2i squared square root of 5. This I squared changes that. So here is a real number, here is a real number. So that's where I goofed up before. I have the negative 5, 6 plus 2 square root of 5 in my parentheses. And then I'm going to take out a negative I between these two. And that gives me 8 square root of 5 plus 14 on that section. And then by doing the bottom, negative 7 times negative 7 is 49. And then we have last times last is Positive times negative is negative. I times I is I squared. And then 5 times 5 inside. We have a pair, so a 5 comes out. This changes this sign because it's a -1. So we have, I believe it was 54. And that's our answer. We've got our real numbers here. Oops. Our real numbers here. Then we're going to subtract our imaginary numbers here. And it's all over 54. And that's our answer. Definitely helps to be a little methodical in doing these. Easy, easy, easy to make mistakes.